here we are. We are going to be talking about AMUs, atomic mass units. Well, did you know that this year our very own Anna Maria Beach on Anna Maria Island was voted #1 beach in the country, best in the US. We have something to be proud about. And why am I talking about a beach? Well, because I kind of feel like going to the beach today. It's such a beautiful day. But actually, what got me thinking about it was thinking about grains of sand. Tell you more in a second. And this got me thinking about another kind of chemistry. Love. Well, that's chemistry too, isn't it? Well, sort of. What really got me started with this whole thing about beach sand is thinking about one grain of sand. One grain of sand contains 2.2 times 10 to the 19 atoms. That's pretty unbelievable. One grain. I'm not talking about one handful of sand. I'm talking about pulling out one little grain that contains that many atoms. Because atoms are so very, very, very tiny. The normal units of mass, grams and kilograms, are way too large to be convenient. So this is why scientists came up with a different way to represent the mass of tiny, tiny particles such as the atom. So this much smaller unit that scientists have come up with is called the AMU, or atomic mass unit. One AMU is equivalent to 1.66 times 10 to the negative 24 grams. Wow, that's a very, very tiny number. Can you imagine how small that number is and how difficult it would be to have to work tiny, tiny numbers like this? Well, that's exactly why scientists worked on this unit and came up with a unit that makes this number equal to 1 AMU. This would be much easier to work with. To give you an example, the average atomic mass for carbon atoms is 12.01 AMUs. In other words, one atom of carbon has a mass which is equal to 12.01 AMUs. So the mass then of one carbon atom could be equivalent to 1.99 times 10 to the negative 23rd grams. But it is a lot easier to work with 12.01 AMUs as the mass of one carbon atom. So these two numbers are equivalent to each other. 0.66 times 10 to the negative 24th. take a moment to do your operation. Pause. Make sure you put parentheses around the numbers as you use your calculator to arrive at the answer. The answer to this question is 1. The answer to this question is 1.198 times 10 to the first. In other words, 11.98 AMUs, which is very close. We round it off to 12.01 AMUs, which is the number that you see on your periodic table, right in the square of the carbon atom. The reason why this number may not be exactly the same is maybe due to rounding, and also keep in mind that this number represents an average mass of atoms because there are 3 isotopes of carbon. So take a look now at these various numbers. On the periodic table, the mass of 1 atom of hydrogen, we can see, is equivalent to 1.008 atomic mass units. The mass of 1 carbon atom, the average mass, is 12.01. Keep in mind that carbon has 6 protons and 6 neutrons. That means that roughly each proton and each neutron has a mass of 1 AMU. For nitrogen, we know that there are approximately 14, in other words, 7 protons and 7 neutrons, which gives us an approximate mass in AMUs equal to 14.01. So we can look at the periodic table and find the mass of the atom of that particular element represented on each square. Okay, so for our calculation now, we want to calculate the mass in AMUs of 635 atoms of hydrogen. Well, we're going to start by writing down what is it that we're looking for. Question mark. We want to calculate the mass in AMUs of hydrogen atoms. So mass in AMUs of hydrogen. We are given 635 atoms of hydrogen. Therefore, we must use the equivalence that we know from the periodic table. So go back for a moment to the periodic table. According to the periodic table, 1.008 is the mass of 1 atom of hydrogen. So I'm going to say, since I want AMUs, I'm going to place AMUs in the numerator, and atoms of hydrogen in the denominator. We know that one atom of hydrogen has a mass of 1.008. Go ahead and do the calculation. The answer is 640 AMUs, because atoms of hydrogen have canceled out. We box in our answer, and that is our answer for this problem. The mass in AMUs of 635 atoms of hydrogen is 640 AMUs. Now I want you to try this out on your own. It is the same type of problem we just solved, and I want you to try it out, solve this problem in your journal. Pause now. Now, we'll discuss that one tomorrow. For this next problem, we're going to calculate the number of argon atoms present in a sample that has a mass of 3,755.3 AMUs. So, first things first, we're going to write down what is it that we're looking for. This is very important that you do this every time so that you know exactly where you're headed. You do not want to start at a problem without knowing where you're going. Just like you wouldn't start driving somewhere without knowing where you're going, because you would drive aimlessly, and that would be a waste of time. So, question mark. Calculate the number of argon atoms. So we're looking for argon atoms. And we know that we are given 3,755.3 AMUs. We know that we're going to find the conversion in the periodic table. So we look for argon, and we know that on the periodic table it says that the mass of one atom of argon is equal to 39.95 AMUs. AMUs, one atom. One atom of argon is equal to 39.95 AMUs. AMUs cancel out. We are left with atoms. Pause so that you can solve the problem. The answer is 94 atoms of argon. We box in our answers, check to see that it is feasible. Does this make sense? Yes, it does, and we've got the correct answer. Write the complete summary and fill in the blanks. We'll talk about it in class. Now that we have completed this task, go ahead, complete it. Now we can get back to the beach.